Hello everyone. Today we're going to talk about an example about optimization. Okay, so this is the example. We have a poster and we know that, well, we don't have it, we want to make it, and we know that the area of that poster is 180 of whatever unit, and we know that we want some margins. We want 1 inch at the bottom and sides and 2 inch margin at the top. So all the sides will have 1 unit except the top, which has like 2 units of margin. So let's say we have something like this, and so from the top we have 2 units, and from the sides we have like 1 unit each, and from the bottom also we have 1 unit. So that means inside we will have um, some smaller rectangle that we're going to include whatever material we want for the poster on the rectangle which is inside. So what dimensions will give the largest printed area? So now we know that the original poster, that means the whole thing, it has 180 units. The area is 180 units. So that means if I call this side to be X and I call this side to be Y, then I will have XY equals 180. So this is something that I know based on the information given in the problem. But then what is that I want to maximize? I want to maximize the largest printed area. I want to maximize the printed area. That means I want to find the largest printed area. So it means that I want to maximize the area of this inside rectangle. So what is the area of this inside rectangle? Very easy to find it, because the outside is xy, the inside, like y, is I have to subtract y, like I have to write y minus 3. Why? Because I have 2 units, 2 margins up, and 1 unit margin down. So it will become y minus 3. And then for this side, I will have x minus 2. So this is the area of the printed area. So this is area of printed rectangle. Okay, so now the goal is to maximize this function, basically. So when you get to this step, then we're basically done with reading the problem. Next step is just using all the techniques that you learned to find the maximum and minimum of a function. So here we're going to work with it. So first, we have to write the area of the rectangle, of the printed rectangle, only with respect to one variable. So I'm going to use the information which was given in the problem, and that was xy is 180. And from there, we can conclude that y is 180 over x. So now I can write, I can replace y with 180 divided by x. And after simplifying, I will get this function. I'll get a of x is this function. So now next step is to find the maximum of this function. Okay, to find the maximum of this function, we know that a very important candidates of maximum of a function are the critical numbers of a function. Another candidates, if we have an interval, we have to check the endpoints of an interval. So here, let's first find the critical numbers of this function. Okay, we find the derivative of the function, and the derivative is negative 3 plus 360 over x squared, and it's very easy to find the zeros of the derivatives. Just set it equals to 0, and the answer is going to be square root of 120, which is equal to 2 square root of 30. You just write 124 multiplied by 30 and bring 2 out. And something that you have to pay attention to it is mathematically we have two answers for this problem, because x when we have this equation x squared is 120, but when we solve this mathematically is plus and minus square root of 120, but you know that that minus does not have any meaning when we are solving a real world problem. So when I'm saying real world, of course it depends on the problem, but here, like, because x is a dimension, so it doesn't make sense to have a negative dimension. That's why it's not acceptable. Okay, so now this square root of 120 is the only critical number that we have. Another thing that we have to pay attention here, we have a border for x and y. So the smallest value that we can have for x is 2. So let's see why is that. So if you remember, the problem is, so we have some poster, and we want to maximize the printed area. Okay, so, and remember that this side is x and this side is y. What is the minimum possible value for x? That means what I can have for x to make the problem making sense. If x is less than 2, then I cannot have 2-inch margins. Like, I cannot have 1 inch in this side and another inch on this side. So the minimum value that I can have for x, for this dimension of the rectangle, is 2. And what is the maximum value for x? If I want to think about the maximum value for x, one way is to think about the minimum value for y, because remember that xy is 180, and this means y equals 180 divided by x. So if I think, like, what is the maximum value for y? So because we have 2-inch margin on the top and 1 inch on the bottom, it means that at least y must be 3. And when y is 3, then, or if I write it in this way, 180 divided by y, when y is 3, x is 60. So that means that's the maximum value that I can have for x. Because the larger x is, the smaller y become, because of this relation, this connection that they have with each other. So it means that we want to maximize this problem on this interval. We have a closed interval, 2 and 60, and we want to maximize this function on this interval. Remember, by extreme value theorem, because the function that we had is a continuous function on this interval, it's not continuous everywhere, but it's continuous on this interval. It means that we can find a maximum, an absolute maximum on this interval. So now, if we are using the strategy that you learned to find maximum and minimum on a closed interval, we have to evaluate the endpoints, and we have to evaluate the function on the critical numbers, and here the only critical number was square root of 120. So if you evaluate all of this, the area when x equals 2 is 0, because remember, the funny thing is that if this is 1 inch, and if x is 2, it means that we will not have basically a rectangle, we'll have a line. So that means the area of it is 0. And if you plug 2 on the function, on the definition of a of x, you'll see that the answer is 0. Also the same for 60, and we evaluate that square root of 120. Obviously the answer is going to be greater than 0. You can check that, you can evaluate this and check it, but you will see that that's greater than 0. So it means that square root of 120 is maximizing this function a of x. So the maximizing dimensions, and remember, the question was not asking about the maximum area, it was asking about the dimensions which are maximizing this area. So it means that, so here we found x to be square root of 120, which is 2 square root of 30, and we can find y, which is the other dimension, and that's 180 divided by 2 square root of 30. And if you want to find this 3 square root of 30, you just simplify. You will get 90 divided by square root of 30, and then you multiply the top and the bottom by square root of 30, and that will become 90 square root of 30 divided by 30, which will give you 3 square root of 30. So that means the dimensions of the maximum area of a rectangle, which makes a maximum area, are 2 square root of 30 and 3 square root of 30. And these dimensions are the dimension of the outer rectangle, because x and y are the dimensions of the outer rectangle. Okay, so have a nice day and bye now.